Hello and welcome back to our second lesson in our last unit, the integral unit of this course. So last class we learned about antiderivatives and we solved for the most general antiderivative. Remember, don't forget to put plus c at the end of our work. And today we're going to learn about integrals. So our last unit is actually called integrals, and there's different types of integrals. There's going to be definite and indefinite integrals. So I'll just introduce the topic of integrals, some notation. We'll talk about the two different types and just do some easy practice questions today. So integration, the integral sign looks like that. Does it look familiar? It should. If you look at the cover of your textbook, well, if you didn't have Nick Batan pasted on it, guess what's on the cover of our textbook? It's the integral sign. So yeah, it's a very important concept to make it on the cover of our textbook, covered with Nick Batan. So you've been seeing that sign every time you've been doing your homework because it is on the cover of our textbook. So that is the integral sign. And I have a little fun fact. Remember, we had two people who discovered calculus. Remember that video we watched way back then in February, which seems like a lifetime ago? Man, the world has changed since we watched that video, but that's another story. So remember, we have two scientists, Leibniz and Newton, who actually developed calculus. I showed you that video. It's a little controversial. So Leibniz is one of the men that was involved in the development of calculus, and he's the one that actually first used this notation for integration. Newton had a different version. We'll talk about that later, but today we'll just focus on Leibniz's, if I'm saying that right. First, use this symbol, and it's actually supposed to be a stylized S, a capital script S, to stand for summation. So if you don't know why summation is connected to integrals, well, you will by the end of this week. So that's where that symbol comes from. And like I said, it's so important, it's made the cover of our textbook. Okay, so that's the integral sign. And integration just means we're finding the antiderivative. So when we found antiderivatives, we were actually finding integrals, certain type of integrals, and I'll explain that right away. So when we look at this first example, yesterday, or last lesson, I would have said, what's the most general antiderivative of x squared dx? And we would have solved for that. Today, instead of saying find the most general derivative, we're just going to use the integral sign. So we know that that means the same thing. So if we did our homework yesterday, the most general antiderivative of x squared dx would be x cubed over 3. And are we done? No, don't forget the plus c. So finding the most general antiderivative is the same as the integral, certain types of integrals. I'll clarify that in the next screen. Okay, so today's assignment is easy because you actually know how to do integrals if you know how to do antiderivatives. And we already talked about the fun fact. So there are two different types of integrals. There's a definite and an indefinite. So a definite will give you the limits of integration and indefinite does not. What does that mean? I'll show you examples on the next screen that clarify the difference about definite and indefinite. Okay, so if they're given the limits, that's definite. If you're not given the limits, that's indefinite. And that's what we did yesterday. If you notice on here, we just did our integral. There's no lower or upper boundary. I did not give you the limits of integration. So if you're just given the integral sign with no limits, that is an indefinite integral. So today's lesson, indefinite integrals, is exactly what we did last class, because indefinite integrals don't have limits of integration, so that's the same thing as finding the most general antiderivative. So today's lesson is exactly the same as last lesson, but just with the integral sign. So just to clarify again between these two different types of integrals, so definite is where you are given the limits. So you have A, B, those are your limits. A would be your lower limit, B would be your upper limit. So when you're given the limits, that's definite integrals. That's going to be our next lesson. We'll have an entire lesson next time on definite integrals, so I'll explain that a little bit more then. But just to realize, if you're given limits, that's definite integrals. That will be our next lesson. And if you're not given limits, then it's an indefinite. So today we're not given any limits. It's an indefinite integral, exact same thing as finding the most general antiderivative as we did last class. So find the integral or the integration of x dx. There's no limits given, so that's indefinite. So I just use my antiderivative rules. So I did give you in that binder that I delivered, there's a pink sheet. So you do have on the front page the antiderivative rules. I summarized some of them with two very funny jokes. And then on the back side, oh, we're going to get to that. There are some integral rules. So if you use this pink sheet, I've tried to summarize most of the antiderivative integral rules. But if you check your textbook on page 322, your textbook also gives you a list of those rules. So there's a couple places for you to find those rules. So we're just going to do one example because you should know how to do indefinite integrals if you know how to find the most general antiderivative from last class. So, like I said, the only difference is same question we would have asked last lesson, but instead of saying find the most general antiderivative, we just put the integral sign with no limits. So we should know our rules from last class. That would be x squared over x squared over 2. Because no limits are given, we put plus c. So all of that 5-minute video to say today's lesson is exactly the same as last lesson, but we've just learned what an integral sign means. So you can try that lesson today, and then next lesson we're going to look at the definite integral. Then we're just looking at area under a curve. We have a couple more topics and we're almost done, so hang in there, but now we get to do some fun integral work to end this course. Okay, good luck.